So on page 238, I'd ask you to look at A and B there. So let's sketch out letter A here. So this is 30 feet here, 18, 28, and 20. There is a girder across here. Now, we didn't do any girder build-ups. We're just talking about the joists, the sills, and the floor covering. So let's start out with the sills. How many linear feet of sill do we need? Somebody be brave. Perfect. 46, 30, 18, 10. What's it come out total? I heard somebody mumble it there. 152 feet, yes. The sill, remember, is just the perimeter. Okay, now the second, what's that?
So basically it could be 30 times 2, 46 times 2, and then add both, right?
Yeah, for this one it could have been because of the way this is set up. It's just, yeah, the 20 and the 10 add up to 30, 18 and 28 add up to 46. So yes, you can just do 30 times 2 plus the 46 times 2 for that one. Okay, so then the second thing I asked you to find was the joists and the length and number of joists. So let's start out. We have 10 footers here that we need. So how many of the 10-foot joists are we going to need? Well, we have a run here of how much for the 10-foot joists? 18 feet. Good. Did I tell you what spacing to assume on these? I believe I said 24 inch, right? Okay, perfect. So 24 on center for our joists. So that means the number of joists for that run is going to be 12 over 24. Or the textbook would have, or the packet would have just said 1/2. It would have simplified it for you. Times my run of 18 feet. Plus, we need to know, is it going to be +1, +0, or -1? +1, because there is a joist at each end of that run. Perfect. So 12 over 24 times 18 is 9. +1 is 10. So there are 10 10-foot joists.
Mr. Hoff, basically the +1 means that because if you were going to lay them out, you would go 24, 48, right down the line, then that +1 covers the one that would have been at 0, right?
Exactly, yes, exactly it. If you're laying them out, you got 24, 48, 72, and so on. As you, oops, 72, not 27. 72 and so on. Dividing by 2 or dividing by 24 inches or whatever gives you one at the end of each run, but you do have to go back and add one to put the one at the beginning. If you were subtracting one, what that would mean is you don't need one at the end. So when we do this -1 for that last thing, that means we get to the end and we don't need one at either end. So we subtract one to get rid of that end one. If it's a 0, that means we need one at one end but not the other. There are a lot of cases where you need one at one end, but at the other end we're transitioning to a different size or whatever, so we don't need it there. You bet. So what's the other length of joist we need? We got the 10 footers. What other length do we need here? That covers this section right here. What else do we need? What length are we going to need here? Be brave, guys. That's going to be 20 feet. Good. So what's our run on those? Somebody said, there it is, 46. So the number of joists we need for that is 12 over 24 times 46. Plus 1, plus 0, or minus 1? Plus 1. We do need a joist at each end. So 12 over 24 times 46 is 23. Plus 1 gives us 24. So 24 are the 20-foot joists. So that's our joists right there. We need 10 10-footers, 24 20-footers. Any questions so far? Now, here's a question I get asked. With I-joists and stuff like that, it is possible to get 30-foot I-joists and run them continuously across here. My background is I've run a construction company for a while, but I've also been a structural engineer for several years before I started teaching. There are some significant considerations for that if you're going to run those across there. I'm going to put, this is one basement wall, this is the other basement wall, and here is that beam across there. If we set our joists across there, and we leave them all as one solid joist, structurally there are some issues. You would think it would actually be stronger than the other possibility, which I'll draw over here. Which is to run two separate joists that are basically a split joist, like this. You would think that this would be stronger. But let me show you what the issue is. Over here, whatever weight we put on this joist, the weight of our floor coming down, half of that's going to go to this end, half is going to go to this end of that joist. The same here. Whatever weight, whatever load goes on this joist, half is going to go to this end and half is going to go to that end. So this beam in the middle is going to have to support 1/2 of the weight of the whole span. In this case over here, what happens? We have weight that pushes down here. Well, if you take a stick and you lay it across like 3 supports, if I push here, it's going to bend that stick down. What's going to happen down at this end? That stick's going to lift up slightly, isn't it? The same is going to happen to any weight that's put over here. Pushing down here, this stick is going to bend down and it's going to lift up down on this end. So what happens in that case if you run that one solid joist across is more than, because of that lift up at the ends, due to the bending of the one solid joist, a minimum of 5/8 of the weight of the total span ends up on that beam. If the beam is sized correctly, it doesn't matter. But a lot of times they make the mistake of only sizing that beam for half of that span because it's a split joist. So if you're going to run they call it a continuous beam or a continuous joist. If you're going to run that joist continuous like that, make sure the engineer or whoever's designing that home knows that you're doing it so that beam is sized appropriately. Now, you might wonder, well, if that's a structural issue and ordering a 30-foot joist is going to be expensive, what would be the advantages of that? Well, these split joists like this tend to cause creaks in your floor because you put weight here, this one's flexing and this one's not, so your flooring is going to possibly going to creak. So there are reasons either way, but I realize the calculations in that is beyond what this class is about, but I like to point that out because a lot of people are, it's a mistake I used to see a lot when I did on-site construction engineering work. Okay, so we have the number of joists. Next, I wanted you to find the number of sheets of or actually bridging would be next. For bridging, and we said bridging only on joists that were more than 10 feet long. So we do not need bridging here because those are only 10 feet long. We need bridging here on the 46-foot run again. How did we figure out the amount of bridging we needed? What number times the run? It was 3 times the run. So the amount of 1x3 material needed for bridging here will be 3 times 46. 3 times 46, what's that, 138 feet of 1 inch by 3 inch bridging. By the way, being that this is a 20-foot span, you're right on the edge of the possibility of having to run 2 runs of bridging. Depending on which standard you're looking at, some of them it's over 20 feet requires a second run of bridging. Some of them it's 20 feet and above require a second run of bridging. Okay, then the last thing we need is flooring. Anybody find the number of sheets of flooring? Want to share what you got? See if you're on. Nobody's going to be brave? Okay, let's take a look. Remember, for flooring, the sheeting for the flooring is just a matter of area. I'm going to go ahead and do this as 2 pieces. This piece here is 20 by 46. This piece here is 10 by 18. Well, this one's easy. 10 by 18 is how many square feet? 180. Very good. Over here, 20 by 46 is 920 square feet. We add that up. 180 and 920 is 1,100 square feet. Divided by 32 square feet per sheet. It'll be 34.375, or rounded up to 35 sheets. If you did it that way and you got that answer, that would be just fine. Now, if I were doing this, remember we discussed that concept of modularizing our dimensions. Modular means divisible by 2 or 4, generally 4, since we're dealing with 4 by 8 sheets. So since this is 46, I would expand this out. In fact, I'd expand the other end, probably be easier. I expand this end out 2 feet. What that does is that makes this dimension now 48. This dimension here is now 20. So both of those come out on the 4-foot standard. 20 feet is fine here. The 10 feet is off. So I would extend this out 2 feet this way to make this 12 feet. Now everything is going to work out for my 4 by 8 sheets to fit in here. So I would have adjusted this to be 48 by 20, which is 960 square feet. And this I would have adjusted to be 12 by 20, or 240 square feet. So I'm actually figuring out for 1,200 square feet instead of 1,100 square feet. So 1,200 square feet divided by 32 square feet per sheet. Oops. $37.5. So I would have figured in 38 sheets. And that should work out exactly to 38 sheets for that. If you're doing the 35 sheets, usually you're going to end up doing, if you're not adding or modularizing your dimension, usually you're going to add a waste factor. We went over this a little bit last semester, but let's say I want to add 10% for waste. So that means we want the whole amount, 100%, plus an additional 10%. So what we want is 110% of what we calculated. The quickest way to find that when you're doing estimating is to take your amount, your 35 sheets, 110% is a decimal, is 1.10, so that is 38.5 sheets. So of course that would round up to 39 sheets that we would use. Any questions on that first example? Did anybody, show of hands, anybody get that first example all right? Did anybody get the first example all done? Okay. Okay, so what I'm going to do then is I'm going to leave letter B as something for you guys to work on for Friday, hopefully. Remind me if I don't remember to come back and go over letter B, because this is something that I would like you guys to be able to know. If you don't get anything else out of this math class, being able to do some of this basic estimating would be one of the bigger skills I'd like you to have. Now, I'm going to assume that you guys didn't get to doing the estimate on 244 for doing the wall studs.
You chatted over it a little bit in class.
Okay.
We ran into a couple of things with the odd length, kind of lost track there.
Okay.
We had a fairly decent handle on a couple of the other pieces. It was just the understanding on it through the odd corners. But we did have a few people gone last Friday.
Okay.
So it might be all right to kind of go over that example B if we can. Let's
do that. I'm going to sketch it in a little rough compared to what they have it, just because my artistic skills are not real refined. This is page 244 in your packet. The way they've got their closet set up here is a little weird too, but that'll work. All I'm really concerned about is making sure I get all the doors and windows on here and any place where an interior wall intersects.
Kids ask what RP stood for in the drawing.
You know, I've been trying to figure that out. I'm thinking it's like a fireplace or something like that. If it's a two-sided fireplace or something like that, is about the only thing I can think of. Yeah, it's an abbreviation I have never seen before. And what it does is it actually makes it difficult. Is this two exterior wall intersections or is it just one? So I guess I would figure it as two interior wall intersections just because it looks like there's two walls coming in, but I really don't know how I would figure that one out. So let's start out here with our shoes and plates, or more often just called bottom plates and top plates. Remember, to find that it's linear feet, it's simply going to be 3 times the perimeter. So what is the perimeter of this one, guys? There you go, 166. And when it's just a simple rectangle like this, the shortest way to do it is just add the length and the width and then take that total times 2. So 83 times 2 is 166. So that's our perimeter. So our shoes and plates, or top plate, bottom plates and top plates, going to come out to a total of 3 times 166, or 498 feet. So you need 498 feet of material for shoes and plates. Studs. The external wall studs, we're just going to do number of studs is equal to, now we're going to go 16-inch spacing on those, so 12 over 16, times that perimeter again, 166, always round up, plus A. So we got to figure out what A is here. So one of the first things we do for A is our corners and starters. How many corners are in this house? 4. Right, there's 4 corners, and we add 2 per corner. So 2 times 4, we're going to add 8 for the corners. Odd length wall is a little bit of a poor term. It should say non-modular wall. This is what happens when you get math people writing textbooks applied to construction. They are adding 1 for each of those 4 walls. They are considering the 30-foot wall to be an odd length wall. You add 1 for each odd length wall. In other words, each wall that is not divisible by 4. Well, this is 53 and this is 30, so all 4 of those walls are considered odd length walls. So that is 4 more for those. There's 1 times 4 walls. What else do we add for, guys? Windows and doors, perfect. How many do we add for each of those? For each window and door, how many studs do we add? 2, good. So we have 2 doors and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 windows. So that's 13 times 2 is 26. What's the last thing we add for? Interior what, guys? I heard somebody say it. Interior wall intersections. And how many do we add for each one of those? Just 1 for each. So up here, interior wall intersections, we have 1, 2, 3, 4, 5, 6, 7, 8. And this is the one I said it's a little bit fuzzy. Is that 1 or just 1, or is it 2 separate ones? We're going to count as 2 separate ones. So 9 and 10. So we're going to count that as 10 interior wall intersections. Remember, we only care where the interior walls hit the external walls. So 1 times 10 is 10. So that adds up to, what, 12, 38, 48. So A is plus 48. So 12/16 times 166. So 12 divided by 16 times, oops, go back there. 16 times 166. Now this comes out to 124.5, which means we round it up to 125. So that's going to be 173 studs. Now if you look at it, they came up with, they forgot to add in for their doors. So that's why they came up with 167. What else did they, there was something else that they did differently, if I'm trying to remember what it was.
I don't think they added 2 for the RP.
Oh, they only did, yep, you're right. They only did one interior wall intersection for that. Or no, they didn't do any for that. So I wonder what that RP stands for. That's going to puzzle me. Okay, yeah, because I mean, I've tried to go through. Is it a laundry chute? Is it a chimney cavity or whatever? And none of them make sense no matter what words I try to put in there. Okay, any questions? Okay, so like I said, try to do letter B on page 238. And we'll go over that one on Friday. So our next step today is I want to get a little bit of a review of negatives, since we're going to start algebraic numbers here and working with algebraic numbers. We do have to have a little bit of pure algebra here just to get you prepared for some stuff. Before we do that, though, I want to review dealing with negatives, integers. Because one of the biggest mistakes, or most of the mistakes that people make dealing with algebraic numbers, come from problems working with integers. So, and not just integers, but negatives in general. So let's take a look at something like 8 plus a negative 5. If you recall from last semester, we represented our numbers, the magnitude of our numbers, on a number line. So we represented them with what we called a vector. 8 was just a vector that went from 0 to 8. So vector is just a fancy word for an arrow that starts from 0 and goes to 8. Now the length of that vector is something we call the absolute value. So absolute value is the length of the vector for the number. Another way of defining absolute value is the distance a number is from 0. So 8 here has an absolute value of 8 because it's 8 units from 0, and the length of its vector is 8 units. The vector for negative 5 would start at 0 and go to negative 5. What's its absolute value? How long is that arrow? How long is that vector? Even though it points the opposite direction, it is still 5 units long. So the symbol for absolute value looks like this. It's just two vertical lines like that. Absolute value of negative 5 is 5. It's 5 units long. So if you recall, when we go to add these integers, these positives and negatives, we take one of the vectors and we put it with the other one. So I'm going to move the negative 5 to combine it with the 8. It's going to look like that. And it ends up at 3. So 8 plus negative 5 is 3. And just like we had mentioned last semester, excuse me, I don't draw out a number line every time we do addition and whatever with negatives, and I don't expect you to either. But I do use that number, the image of that number line, to tell me what to do. If I have negative 27 plus 19, what I am thinking in the back of my head is here's 0, negative 27 goes this direction. 19, does that go the same direction or the opposite direction? It's positive, so it goes the opposite direction. Is it longer or shorter? It's shorter. Good. It has a smaller absolute value. It's shorter. Negative 27 has an absolute value of 27. 19 has an absolute value of 19. It is short and smaller absolute value, so it's a shorter vector. So what that tells us is we end up on the negative side of 0. So our answer is negative. And since the arrows, the vectors point in different directions, the value is the difference between the absolute values. So 27 minus 19, which is going to be 8. So this is a negative 8. Well, we went over that part last semester. So this semester, I want to add in, what if this is, I'm going to keep this visible for now. What if this is negative 13.7 plus 4.9? So we put in some decimals. The picture looks the same. Here's 0. Negative 13.7 goes this way. 4.9, same or opposite direction? Same direction or opposite? Opposite direction. Longer or shorter? It's shorter than 13, right? So we're staying on the negative side of 0. Our answer is negative. And again, the arrows go opposite directions, so the result is the difference between their absolute values. So we're just going to take the bigger number, the bigger absolute value minus the smaller absolute value. 13.7 minus 4.9. We have to borrow from the 3. This is 17. This is 8. Bring down the decimal. Borrow from the 1. That's 12. Minus 4 is 8. So the answer here is a negative 8.8. So we might have 17.2 plus a negative 11.9. So from 0, which direction do I go? Positive or negative? You start out going positive, how far? 17.2, right? Doesn't really matter how far, just as long as we do comparatively. The negative 11.9, same direction or opposite direction? Opposite, longer or shorter? Shorter. So we're going to end up on the positive side of 0. Now, do the arrows go the same direction, or they don't go the same direction, they go opposite directions. So it's going to be the difference between the values. 17.2 minus 11.9, which will give us 5.3, right? So a positive 5.3. So let's say I have a negative 13.4 plus a negative 18.7. So I start out at 0. 13.4 goes this way. Negative 18.7, same direction or opposite? Same. So since they go the same direction, it doesn't matter if it's longer or shorter. It's obviously on the negative side because they're both going negative. Do we add the values or subtract the values? Since both arrows go the same direction, we add the absolute values. So it's 13.4 plus 18.7, which is going to give us 32.1. So it's a negative 32.1. Now I realize your calculators can do a lot of this for you, especially with the decimals. If you don't have a fraction calculator, dealing with the fractions for negatives is going to be a little bit tricky. So let's take a look. Let's say we have 4 and 7/8 plus a negative 3.5. So starting at 0, 4 and 7/8 is positive, so we're going to go that direction. Negative 3.5, same direction or opposite direction? Opposite. Longer or shorter? It is shorter. We can always just compare the whole numbers. 3 is smaller than 4, so it's going to be shorter. We don't have to. We're not trying to be to scale or anything like here, so we don't have to. We can ignore the fractions as long as the whole numbers are different. So here we definitely end up on the positive side. The arrows are opposite directions, so we're going to subtract the values. 4 7/8 minus 3 1/2. Now I'm not going to go through the whole fractional subtraction finding common denominators right now. I'm going to trust that you guys can do that. That's 1 3/8 inches. So that is a positive 1 3/8 difference. I really shouldn't put inches on there because I didn't label them inches to begin with. So what if we have a negative 8 1/4 plus 11 1/2? So here's 0. Negative 8 1/4 goes this way. 11 1/2, same or opposite? Opposite, longer or shorter? Longer, so we go past 0. Into the positive side of things, they're still opposite directions, so we're still going to subtract the absolute values. So it'll be 11 1/2 minus the 8 1/4. Give us 3 1/4. So this is a positive 3 1/4. Now, if you recall, we did subtraction. When we subtract 8 minus 3, if we look at our picture of that on the number line, or illustration on the number line, eight minus 3 would have been illustrated something like this. There's 8. We go back 3 to get 5. We know that 8 minus 3 is 5. Looking at this picture, however, if you recall, that's the same illustration as 8 plus a negative 3. And we talked about that definition of subtraction. Remember, the subtraction symbol works with the number that comes after it. Minus 3 is really saying add the opposite of 3. So we added the opposite of 3 is negative 3. Well, if both numbers are positive, like 8 minus 3, we can just go ahead and subtract because we know how to subtract. It's when one of the numbers is negative that we have difficulties. So if we have like negative 11 minus 7, that's going to be a little trickier to do unless we change it to addition. The first number never changes. That stays negative 11. It's the minus 7 that becomes plus. The opposite of 7 is a negative 7. And now we can draw our vectors. Negative 11 goes this way. Negative 7, same or opposite? Same, right? It's negative 11. They're both negative. So that tells us our answer is clearly negative, and they're both in the same direction, so we add the absolute values. 11 plus 7 is 18, so it's a negative 18. So we might have a negative 42.3 minus 19.8. So what's going to happen to the negative 42.3? Say nothing. There we go. It stays negative 42.3. What happens to the minus, subtract 19.8? It becomes plus what? Perfect. Negative 19.8. So now in our vectors, here's 0, negative 42.3, negative 19.8 goes the same direction. Answer is negative, and we have to add the absolute values. 42.3 plus 19.8. 62.1. So it's a negative 62.1. So if I have a 17.4 minus a negative 28.3, what happens to the 17.4? Careful. Nothing. There we go. 17.4 stays 17.4. What happens to the minus a negative 28.3? It becomes add the opposite. Plus, what's the opposite of negative 28.3? Positive. There you go. Positive 28.3. So in our picture, here's 0. 17.4, 28.3 goes the same direction. So this is going to be a positive. They're the same direction, so we add them together. 45.7. What do you guys think? Better than a sharp stick in the eye? Possibly. Let's try it. I'm thinking maybe we'll not do that. I'm pretty sure that's against some sort of school code of conduct somewhere, so we'll maybe pass on that one this time. So here with fractions now. 8 1/2 minus a negative 2 3/4. What happens to the 8 1/2? Say nothing again. Nothing again. There you go. How about the minus 2 3/4? Minus a negative 2 3/4, I should say. Change to positive. Perfect. There it is. Plus a positive 2 3/4. So it's 0 plus 8 1/2 plus another 2 3/4. So it is, we add those together, 8 1/2 plus 2 3/4 is going to be 11 1/4. So it's a positive 11 1/4. It's 2:45. You guys want to go ahead and take about a 3-minute break?
Okay, sounds good.
Okay, so our next step is to multiply. Now, a quick review again of our integers. If we had a negative number times a positive number, so negative 4 times 9, is our answer going to be positive or negative? Negative, and 4 times 9, of course, is 36, right? So negative 4 times 9 is negative 36. If I have a positive times a negative, my answer is going to be positive or negative? Careful. Positive times a negative will be negative. Good. Let's keep it down, guys. Hands to ourselves back there. 12 times 2 is 24. So 12 times a negative 2 is a negative 24. So now if I have two negatives multiplied together, let's say I have a negative 7 times a negative 5. A negative times a negative will be positive. So 7 times 5 is 35. So we have positive 35. So when I'm dealing with any of my other forms of numbers, it's going to be pretty much just the same way. If I have a negative 1.44 times 1.2. Is that answer going to be positive or negative? Negative 1.44 times a positive 1.2. Positive or negative? Negative times a positive is negative, right? 1.44 times 1.2 is 1.728. If I have 3.5 times a negative 2.4, is my answer going to be positive or negative? Which one? Negative. Very good. A positive times a negative is a negative. It is going to be what? Negative 8.4, right? I'll double check that. Yep, negative 8.4. If I have a negative 4.5 times a negative 6.8, the answer is going to be what? Positive. Very good. And we'll cheat and use the calculator to multiply them out. 4.5 times 6.8. So it's a positive 30.6. Now, most of you hopefully have figured out how to use the negative key. If your calculator is like mine, you've got this negative key down here. It's the minus in parentheses that you use for negatives. Instead, you don't use the subtraction key for most calculators. So I could enter a negative 4.5 times negative 6.8. It does give us the positive 30.6. Now, my calculator doesn't do fractions well, but most of yours will. If I have 2.5 times a negative 5 3/4, is my answer going to be positive or negative? It will be negative. I have a positive times a negative is going to be negative, no matter what kind of numbers I'm working with. So now I just have to multiply my 2.5 times 5 3/4 to get the magnitude of that number. So remember, when we're multiplying mixed numbers, we have to change them to improper fractions. 2 times 2 is 4, plus 1 is 5 halves. 5 times 4 is 20, plus 3 is 23/4. 5 times 23 is 115. 2 times 4 is 8. So it's 115/8. Have to split that back into a mixed number. 8 does not go into 1. 8 goes into 11 once. That's 8 with 3 left over. Bring down the 5. 8 goes into 35 4 times would be 32 with 3 left over. So that's 14 3/8. So that is a negative 14 3/8 for our answer. So when you're dealing with the fractions, again, you just have to figure out what sign the answer has to be when you multiply and when you divide, and then actually combine the numbers. I'm not going to do a lot of examples of division, just because all it is dealing with the signs. But if I have a negative 8 1/8 divided by 2 3/4, is my answer going to be positive or negative? Careful. Negative divided by positive will be negative. So now once again, I have to change these into improper fractions. 8 times 8 is 64, plus 1 is 65/8. 2 times 4 is 8, plus 3 is 11/4. What's my next step? Let's see what you guys remember here on fractions. I do the zigzag multiplication, but before I do, normally what we'll do is we'll take the reciprocal, right, and multiply. So instead of dividing by 11/4, we're going to multiply by 4/11. Now we could do the cross multiply or cross cancel. 8 and 4 both reduced by 4, giving me 2 and 1. 65 times 1 is 65. 2 times 11 is 22. That'll reduce to 2 and 21/22. So it is a negative 2 and 21/22. So again, it's just a matter of looking at the signs. A negative divided by a positive has to give us a negative, and then just doing the operation with the number. Okay, we talked briefly last semester about doing powers and roots with negatives, so I want to take a look at that quick. If I have negative 3 squared, squared of course means that's negative 3 times negative 3. What's that have to come out to be? Positive 9, right? Negative times a negative is a positive. So it is a positive 9. If you punch that in your calculator, if you recall, some of your calculators might try to tell you it's a negative 9. Do you remember what you have to do to avoid making that mistake? Like my calculator here, if I do negative 3 squared, it's going to try to tell me it's a negative 9, but that's not right. What would I have to do on my calculator to make sure it comes up as a positive 9? Parentheses, very good. Put the negative 3 in parentheses and then squared. Gives me positive 9. To make sure the calculator squares the negative, not just the number, and adding the negative sign to it. If I have negative 4 to the power of 5, am I expecting that answer to be positive or negative? Well, let's take a peek at it. That is saying I have 5 negative 4s multiplied together. So let's go through and do it. Negative 4 times negative 4. Well, negative times a negative is a positive. 4 times 4 is 16. Times the next negative 4, 16 times negative 4. Positive times a negative is a negative. 16 times 4 is 64. Times the next negative 4. So negative 64 times negative 4. Negative times a negative is positive again. 64 times 4 is 256. Times the last negative 4. 256 times negative 4. Positive times negative is negative. 256 times 4 is 1,024. Negative 4 to the 5th is a negative 1,024. So negative 3 squared was positive, but negative 4 to the 5th is negative. Why is that? Let me show you a couple more examples here and see if you can find the pattern. Negative 3 to the power of 4 is a positive 81. Negative 5 to the power of 6 is a positive 15,625. Negative 2 to the power of 10 is a positive 1,024. Negative 3 to the power of 6 is positive 729. However, if I have negative 4 to the power of 5 is negative 1,024. Negative 5 to the power of 3 is a negative 125. Negative 3 to the power of 5 negative 243. Negative 2 to the power of 9 is a negative 512. So over here, all these came out positive, all these came out negative. What's the difference there? Odd and even, very good. When we have an even power, the result will always be positive, no matter whether we start out with a negative number or a positive number. An even power always gives a positive result. An odd power will give us whatever sign we started with. All these were negative, so we ended up with a negative result. Got to be careful because we can have 7 to the power of 3. Even though that's an odd power, it's still going to be positive because we started with a positive number. Now, because of that, if you recall, our roots are the reverse of a power. A square root of 49 is asking us what number squared equals 49. Well, what's the square root of 49? 7. Very good. Now, there is another possibility. Negative 7 could also be an answer to that, because 7 squared equals 49, but negative 7 squared also equals 49. Now, of course, this symbol is a third root. The third root of 64 is asking us what number the power of 3 is 64. When we did this one earlier, do you remember what it was? 4 to the power of 3 equals 64. On your calculator to do a third root, some of you have a third root key. Others have an X root or an N root key like that. You have to type in the 3, hit your X root or N root, then type in the 64. Notice I didn't say 4 or negative 4 here, because here 4 to the third power equals 64. But a negative 4 to the third power is not 64. It's a negative 64. So when it's a third root, we only have one answer. That comes back to what we were just talking about up here. The even powers will always give a positive answer, whether it's a positive or a negative that we start with. So even roots, this being a square root, is going to give us two answers, positive or negative. If we did a fourth root, the fourth root is 625. Well, that's going to be 5 or a negative 5. Because 5 to the fourth power is 625, but negative 5 to the fourth power is also 625. The third root only gives us one answer because when it's to the power of 3, to an odd power, it can be a positive number or a negative number. If I wanted to get a negative 4, I would do the third root of a negative 64. That would give me an answer of negative 4, because negative 4 to the power of 3 is a negative 64. However, if we go back to our even roots, what's the square root of a negative 36? Remember, that's asking us what number squared equals a negative 36. Well, what do we know about a number squared? The result is always going to be what? You've got that confused look on your face like you just punched it in your calculator and you got something unexpected. When you did the square root of negative 36, what did it tell you? Should have said error, right? Yeah. There is no number that if we square it, that's going to give us a negative result. When we square something, because it's an even power, the result will always be positive. So for that reason, we cannot take a square root of a negative number. For the same reason, we tried to do the fourth root of a negative 16. Because that's an even root, we cannot do the even root of a negative number. We can only do negative numbers with odd roots, not even roots. So if I want to do the square root of a negative 1.44, what am I going to get? What did it tell you? It's an error. Very good. It's the square root of a negative number. If I want to do the third root of a negative 1.728, what are we going to get? Well, it's a third root, so I can do a negative number. Now, a lot of you, your X root key is going to be above your power key. So you would type in 3, then you have to do second, and then hit your power key. My X root key is in one of my menus here, so I have to dig it out of the menu. So I have to do the third root of a negative 1.728. Oops, I put my decimal in there. Third root of negative 1.728 is a negative 1.2. So remember that. Even powers are always going to give a positive result. But because of that, you cannot do the even root of a negative number. Odd powers will give you back whatever sign you started with. Because of that, you can do an odd root of a negative number. Okay, so we've got two things for today. It's a little earlier than normal, but we've got homework here for you. This is in the big book. Starting on page 213 and going through page 216. This is in the unit exercises at the end of the chapter. 1 through 91, looking at the odds. Now, I don't expect you to do 46 problems of these. You'll make sure you do at least a few out of each section so you know you're doing them okay. And then there should be a quiz for you guys to do. Mr. Berghammer, you got a quiz ready for them?
Yep.
Perfect. So I'll have you guys work on the quiz first, if you will, and then work on the homework after the quiz.